Okay, so let's look at another one. Y equals 4k minus x. And then we're also going to say that y equals 3k minus kx squared. Okay, so again, this is a line. This is a frowny face graph. So I want to find, so I'm being asked to find two values of k. So what does that tell you about the discriminant? Okay, the discriminant is going to be greater than 0. It's positive. Two values of k where the line is a tangent.
Easy.
Okay, I'm going to give you an idea about what that looks like graphically. So I've just told you that there's going to be two values of k, but if you have a graph, you could have a line that does this, and you could have a line that does this. See what I mean? So you can have two different equations. You can have two different spots. Let's just go through and have a look at it. So I'm going to do exactly the same thing as what I did last time. So what am I going to do first? Make them equal each other. So 4k minus x equals 3k minus kx squared. Let's bring it. Yeah, because I'm a genius. No, it's 3x. Okay, so then we have 4k minus x minus 3x plus kx squared. So then I have, well, equals 0. Let's do that. So then I have kx squared minus 4x plus 4k equals 0. All right, so I am being told this is a tangent. So what does the discriminant equal?
0.
Right. So my discriminant is b squared minus 4ac. So what's b? Negative 4, right? Remember, so this is a, b, and c. So negative 4 squared minus 4 times a, which is k, and then c, which is 4k. Correct? Okay. Can you see that this is going to be a... What? Because the discriminant equals 0 if it's a tangent. Right? This is the discriminant. If there's one point of intersection, the discriminant has to equal 0. Yes? No, we don't know what k is yet. We're trying to solve for k. That's what we're doing right now. Right? Because that's the only unknown I have. It's just k. So negative 4 squared is 16 minus 4 times k, which is negative 4k, times another 4. So I have negative 16k squared equals 0. Right? I'm just multiplying this. So then negative 16k squared equals negative 16. Bring it across. So then k squared equals 1. So then k is positive and negative 1. Right? You must take the positive and negative square root. Make sense? Oh, you are being quite annoying. Yeah. Do you get what I mean here? So these are my two possible values of k. Yeah, that's all it asked for. Just what are the two values of k if the line is a tangent? So if there's only one point of intersection, the discriminant must be 0. And then so I use the discriminant to solve for k. Part B is now going to ask for something else. Can I what? I can't. This is a real problem with this projector, and I've already spoken to IT about it. I really can't make it less grainy. Like, unless I just make it, yeah, but then I can't write on the screen. I can't fit everything in. And then I have to write that big for you to see it. I know it's really annoying. I'm really sorry about it. I wonder if I get a thicker pen, if that's going to help.
No, this is the fourth one to the top, like fourth. No. The same one.
Oh, it's that one. Yeah, you're right. Okay, let's see if this helps. Okay, so let's pick another color. Sure. But there is no pink. It's light red. There used to be a pink. All right, so what I'm being asked to do now is say, find the two coordinates. That is not thicker.
I think it's also partly because it's different.
Shut up.
So find the two coordinates. This is the easy bit, right? So the question is going to say, oh no, just find the coordinates. Okay, so what are my two coordinates of K? +1 and -1. So what I'm going to do is go back to, see, this is the problem. I need more of the screen. So this was my equation, right? So I know that K is -1 and -1. So we've got kx squared minus 4x. So kx squared minus 4x, was it plus 4k? Come on, people, you got to help me. Plus 4k. Plus 4k equals 0. So what we're going to do now is plug in one of each. All right, so let's make it equal 1. So then we have x squared minus 4x plus 4 equals 0. So what are my two solutions? Good, -2, -2. So x is 2. And then for my -1 solution, I've got negative x squared minus 4x minus 4 equals 0, which means I've got to take the negative out. So then what are my two solutions here? Good, +2 and +2. So that means x equals -2. So these are my two x solutions. How do I get the actual coordinates? Yeah, put it back in the original one, get my two different equations, which I have run out of room to do, but you know exactly how to do that bit.
Into the original.
Yeah, into the original ones, right? So let's do it over here. Okay, so if we've got this one here. Oh yeah, that's really awful, isn't it? Well, I mean, it works on here, so I'll save it all and put it all on Google Classroom. This is the thicker one. Yeah, it is. You're right. I'll keep it as thicker. Okay, so this one over here, I'm going to take this equation up here. So I've got y equals 4k, which we said is 1, minus x, which is 2. So y is 4 minus 2, which is 2. So that coordinate is 2, 2. And then let's pick another color for this one here. So x is -2. And I've got, yeah, we'll do the same thing over there. So y is 4k, which is -1, minus x, which is -2. So y is -2. So this point is -2, -2. All right, does that make sense? I'm so sorry about the quality of the screen. It's not helpful at all. All right. Yeah, it is recording.
Is it like as bad?
No, it looks perfect on my screen. Okay, let's have a look at a circle equation in the form that we're used to. So I was just using quadratics. Let's look at another actual circle equation. Okay. So let's look at a circle equation. So if I have x minus 1 squared minus 1 plus y plus 2 squared, well, actually it should be a minus 4 minus 5 equals 0. Okay, if I'm given something like that, just fix that. Should be a minus. All right, first of all, let's rearrange this. I need this to look like a normal circle equation, don't I? So first of all, what is, yeah, let's do that. So x minus 1 squared plus y minus 2 squared equals what? What goes on this side? 10. Okay, so what is the center? 1, 2. And what is the radius? Right, root 10. Okay, so this is the information we can gather from our original equation. Okay, we are told that there is a tangent at 2, 5. Okay, so then what I want is the equation of the tangent. So I want the equation of the tangent. The tangent to the circle. Sienna, what did you tell me about tangents and circles before? Okay, they are perpendicular to the radius. This is a point. Do I have any idea where this point might be? It has to be on the circle. Why does it have to be on the circle? Because it's a tangent, right? They're saying the tangent is at this point. So we've got a point of the circle and we have the center of the circle. Can we find the length of the radius? Do we need to find the length of the radius? What do we need to find? The gradient of the radius, because as Sienna just said, this is going to be perpendicular.
We have 2 points.
Exactly. So the gradient is, I've got a point of 2, 5 and 1, 2. So I'm going to do 2 minus 5 over 1 minus 2. So then I get -3 over -1. So my answer is 3. So if my gradient is 3, what's the gradient of the tangent line? Good. So my new gradient is -1/3. And I have a point. Don't I have a gradient and a point? So y minus y1 equals mx minus x1. So y minus 5 is -1/3 x plus 2/3. So then y equals -1/3 x plus, 5 is 17. So this is the equation of the gradient to this, of the tangent to this circle equation that goes through this point. Okay? Okay. Is the big writing helping?
Yeah.
Oh, good. That does help. All right, let's do, oh gosh. Yeah, let's do one more. No, we don't need to do that one. Okay, I just want to remind you of one more thing, and I'm definitely going to use the circle shape for this. All right. Oh, geez. Shut up. Okay. So if I want to draw a circle, I just want to remind you of some properties of circles. Where is my lovely diagram? So I can just do that. Okay. If I draw there we go. All right, if I draw a line through the circle, if I draw a point at any point on the circumference, what do you know? What do you know? If I use this as a line of a triangle that I'm going to make what's 90 degrees?
The circle shape.
Good.
It's tight.
Okay, it doesn't matter where I draw this, right? I can draw it over here. It makes no difference. Wherever I draw this line, if they both attach to the corners, this is always a right angle. That is also true. So if I do that, I also want you to think about any line that I draw from the circle center to the outside. What do you know about them? They're all equal, right? Every line that goes exactly. So I can make a heap of isosceles triangles and I can split them into right angles if I need to, but you don't always have to do that. So think about all of the properties that you can get from these triangles, okay? The more you remember about your circle geometry and your geometry rules in general, the easier this is going to be. If you want to have a look at a much better version of some of the stuff I just drew, the bottom of page 63 has a really nice circle picture there that gives you some circle properties, which is super useful. All right. You should still have your timetables.